Hello everyone, in this video we are going to discuss the solution for maximum sum. So let's see how we can solve this problem. Alright, then let's study our question first. So in the question we have been given a number in the form of string. Okay, and we have been told that we can swap two digits at once. Okay, and we have to find the maximum valued number by swapping only two digits. Meaning we can swap only one time. And we have to create maximum value number by doing that operation. Okay, so let's take one example, a sample example, 2736. Okay, so we have to do one swapping operation such that it become the largest number possible by doing only one swapping. Okay. So we can swap this, we can swap this, we can swap this, we can swap this, like this. Okay, let's count. We can swap this, this, and this. Then we can swap this, this, and this. Okay, and our last swap could be this and this. Okay, so this is how we can do multiple swappings. So a simple method or the name method could be, we try to swap each and every pair and see which of the following gave me maximum valued number. Okay, so for that I will need extra space, because in my example I may have got only 4-digit number which can be stored in our integer. But let's say if I have 20 length string or 30 length string, it won't be possible to store it in integer or even long has capability of storing 18-digit numbers. So even long won't be able to store these numbers. Okay, so first thing, we will have to store all the result that we are forming. Also, for doing multiple swaps, it will take at least n square time. Okay, so that approach is not viable, so we have to move further. So there could be one more approach, that we find the next greater element. Okay, so 2736, we find next greater element is stored at which index? So index 1, index 3, because there isn't any number which is greater than 7. Index 3, index 3. Okay, such thing like this, and we just try to swap. Now this is at 0, this is at 1, we can swap it. Okay, so this could be one possible solution. Okay, such like this we can have multiple solutions. Okay, we can either swap this and this also. This is also one valid answer. Okay, we have improved our previous method, but it will still take memory, extra memory, at least on of more space. Okay, so we can improve it much further, and we can develop a more optimized approach for it. Okay, and how we are going to do this? Let's take one example. Let's say 9 9 8 7 5 6 6 3 1 7 7 4. Okay, let's say this is my number, and I have to find maximum number by swapping only once. So this time I'm going to store the last index at which one number is stored. What do I mean by that? Okay, let me write it first. 1 2 3 4 5 6 7 8 9. I'm going to store at which index this number has come last. Okay, so let's write it. all the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. Now let's write their indexes. So 9 come at 0. Okay. Then it comes at 1. 8 come at second index. 7 come at third index. 5 come at fourth index. 6 come at fifth index. 6 again come at sixth index. 3 come at seventh index. 1 come at 8 index. 7 come at 9 index. 7 again come at 10 index. 4 come at 11 index. Okay. Now I have the result at which all these elements come last time. Okay, now what I'm going to do with it? Now I know that on the leftmost side I have my most significant digit, and on my right hand side I have least significant digit. Okay, I have to make my most significant digit greater, and I don't care what happens to my least significant digit. Okay, I have to do some swapping like this, that my most significant digit becomes greater and least significant digit uh, decreases. Okay, we have to swap like this. All right. So when I have written the last indexes for all of these numbers, now I have written for which this number is existing at last. So let's go all over the array once again, and I'm sure that you will be able to see what I'm trying to tell you. Okay, so I reach at 0. I have 9. So 9 is already at maximum place. We travel again. We found 9 again, which means we don't have to swap anything. Now we reached 8. Now this 8 can be replaced by what number, so that this entire thing can become greater. This 8 can only be replaced by 9. If it is replaced by 9, then only this number will increase, right? So if I will see where is the 9, 9 has come at first index in the last time. Okay, if I will try to swap these two numbers now, 8 and 9, if I will swap them, then the overall value of my number will decrease. That's what I don't want. So at least the number that I have to swap with, for example, I had to swap 8 with 9, then the last index of 9 should come before, uh, should come after this 2. If let's say instead of this 6 I had 9, then I would have easily swapped this 8 with this 9. Okay, but this isn't the case here, so I'm not going to swap it, and I will move further ahead. Okay, now I have 7. Okay, so to make this entire number larger, I have to replace this number with either 9 or 8. Okay, even if I replace it with 7, the number's value won't change. I have to strictly increase my value. So I will have to either swap this 7 with 8, 9 or 8. First I will try to swap it with 9, then I will try to swap it with 8. If swapping with 9 is not possible. Okay, so I try to check with 9. Okay, it comes at first index, so obviously can't swap it. And now I check with 8. I have made a mistake maybe. So this should be right. So at 7, this 7, can it be replaced by 8 anyway? Isn't 8 anyway? Because the 8 last has come at index 2. So we won't be able to replace it. So it will remain as it is. Okay, now we have 5 here. Now 5 can be replaced with either 9, 8, 7, 6. If we try to replace by any of these numbers now, we will increase the value of our number. If we will try to swap it with any other number now, we won't be increasing our value. Okay, so let's try to do it with 9. Can we swap it? No, we can't. Can we swap it with 8? We can't. Okay, now for 7. The last value for which the 7 has come is 10 here. So 7 is here and 5 is here. If we can swap them, the overall value for my number will increase. So I will do that. I will swap these two, and my new number will become 99877663175. Okay, so now I have the largest number by doing the math only one swap. Okay, if I could have done multiple swaps now, I would have been easily able to swap all the numbers and put it in the descending order. Okay, so this was one example. Let's take one more example. Five, six, seven, eight, nine, 9, 7, 3, 3, 4, not 8, 5, 6, 6, 3, 2, 1. Okay, so this is my number now. Let's put the indexes 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's go from left to right and put the last indexes. So for 9 we have 0, for 7 we have 1, for 3 we have 2, for 3 again we have 3, for 4 we have 4, for 5 we have 5, for 6 we have 6, for 6 again we have 7, for 3 we have 8, for 2 we have 9, for 1 we have 10. Okay, now let's go over it again. Can we swap this 9? It's not required. Okay, now we will try to swap up 7. 7 can be swapped with 9, 8. Okay, 9 and 8. 9 has come at index 0 and 8 hasn't come at all. So basically we can't swap 7. Now for 3. Which numbers can swap it? 9, 8, 7, 6, 5, 4. These numbers can swap it. So let's start with 9. 9 can swap it. 9 is already at higher place. It won't be necessary to swap it. 8 doesn't exist. 7. 7 has come at index 1. So it can't swap it. Now 6. 6 has last come at index 7. So definitely this 3 can swap with 6 to increase the number. Okay, so my new number will become 9, 7, 6, 3, 4, 5, 6, 3, 3, 2, 1. So this will be my new number. So that's how we have to perform swapping. First, find our last index, then go all over our array and try to check from 9 to that number. is it possible to swap it? And if it is possible to swap it, then we swap it. Okay, and we have to swap it only once. So for that we will need some Boolean flag. Okay, so that we only swap it once. Now if you think about it, if I put some count there, we can actually make it for more than one swap. Okay, so now let's code it. Okay, all right, then let's code it now. Now the string in the Java is immutable, so we can't actually swap the elements or the characters in the string. So what should we do in this situation? One thing can be done is that either we can use string builder. First we write it all over the array and use the string builder to store entire thing. Okay, second thing could be we use arrays. What kind of array? Either character array or the integer array. Okay, it doesn't matter what you use, you just have to remember that string are immutable. All right, so let's do this. So I'm going to use character array. Okay, so arr equal num dot to char array. Okay, so that's it. Now I have character array. Now I have to travel all over this character array. Int I equal to 0, I less than arr dot length I plus plus. And now I am traveling all over this array so that I can store my last index. Okay. Not n, it should be 10. And why 10? Because digits are from 0 to 9. Okay. Now I am traveling all over the array and I have some characters and I have to put the value for the each character. So I will use simply this arri minus 0 character, the ASCII mathematics. Okay, and I'm going to store the last index for that. Now as I said before that I have to use a Boolean flag. Okay, and Boolean flag will tell me that I have swapped once. Okay, so for that, for int I equal to 0, I less than arr dot length I plus plus. Okay, now for checking from 9 till my this arri, int j equals 9, j is greater than arr I minus 0 character and j minus minus if the index of this j lidx j is greater than my current index, then only I can swap. So we are going to swap. So let's take temporary character which is going to store arr I and arr I is going to now store arr lidx of j. Okay, and arr lidx of j is now going to store temp. Now we have swapped it. Okay, so flag will turn to true. and this loop will break because we have to run it only for once. If flag equals true, meaning that swapping is done, then break this loop also. Alright, now we just need to create our answer string because currently we have characters. So let's do it. So let's create string. Let's use string builder. Okay, let's use string only. Answer equals to empty string first. Same loop for int I equal to 0, I less than arr dot length I plus plus. Okay, answer plus equals and arr I. That's it. Return answer. Okay, so let's run it now. Oh, Boolean flag equal flag. It should be false. Let's run it now. So we got successful submission for our sample test case. Let's submit it. So it passed all the test cases, which means our code is correct. Now let's talk something about its time complexity. Now you can see that this loop run for, let's use red color. This loop run for O of capital N. And this loop, what about this loop? How many times this is going to run? You are going to say n square time, but look carefully. This is running for at max 9 times. Okay, so 9n times, or simply O of n times. So overall time complexity for this entire function will be big O of n. Okay, and what about the space complexity? We have used an array, so this array is going to cost us something, which will be O of n. Okay, and you are going to say this new int 10 lidx array, it is going to add to our space complexity as well. Actually, this is not going to add anything to our space complexity because this is a constant space of 10 integers. Okay, so our space complexity is O of n because of this character array that we have created. Okay, we have to create this array because in Java strings are immutable. Okay, so that's all for the solution of maximum swap, and I hope that you have understood it very well. Okay, so that's all for this video, and I will see you in the next one.